All right, we're going to bring this section to a close here, talking about the proper way to wisely use these two-sample T procedures. Mentions when you're planning this two-sample study, it is best if you could choose equal sample sizes, although it's not a requirement and doesn't have to be the case. I think the really important thing here is to remember that you should not be using the pooled two-sample T procedures. Those are exclusive to proportions that involve z-scores for significance tests only. Okay, never with means. Means are specific to t-scores. Okay, we remember this with our ZAP TACS acronym. Means are t-scores, proportions are z-scores. We should never be doing any pooling with t procedures. Okay, you do not want to use a two-sample T procedure on paired data. And we're going to take a look at this here in the next example, just to kind of talk through the difference between when you're pairing the data up together versus actually taking two samples, one from each population. And please make sure that you're just being very careful that you're beware of making any inferences in the absence of any randomization taking place, whether it's randomly assigning treatments or that you've randomly selected the people who are participating in your study. You cannot generalize your results to a larger population. You can only generalize your results to those individuals who participated in your study if they were not selected randomly. Okay, so we're going to kind of compare here the difference between a paired t-test, and a two-sample t-test. Okay, now the paired t-test is really when we were looking at doing a matched pairs design. We studied this a few chapters back. This is exclusively really one sample where maybe you're taking two data values and you're recording those from the same individual. So maybe you would record your resting heart rate and then you would record your standing heart rate. You are an individual who has undergone both treatments. This is what we would consider to be a matched pairs design. It would fall under a paired t-test. Another situation that could fall under a paired t-test would be that you're taking one observation on each of two similar individuals. So maybe a set of twins that you have, and you would have each of them undergo a different treatment group. So the two individuals are similar. That is a paired t-test. That would definitely not be a two-sample t-test. I think the key distinction here is when your paired data results from measuring that same quantitative variable twice, you can make those comparisons by looking at the differences in between your pairs. If you're measuring the difference is really the single set of data that you're using, and that's why it's just a paired t-test versus a two-sample t-test comes from actually getting two independent samples. And so we're going to read through just a couple examples, and we're just going to see if we can categorize whether we feel like this would fall under a paired t-test. By the way, on the calculator, it's not called paired t-test. It is simply called t-test. Okay, versus a two-sample t-test. These are two things that are very easily confused here. All right, so we want to just determine which test should be run in the following situations. The first situation is to test the wear characteristics of two tire brands, A and B. One brand A tire is mounted on one side of each car in the rear, while a brand B tire is mounted on the other rear side. Now, which side gets which brand of tire is determined randomly by flipping a coin. So the question is, do we feel like this situation would warrant a paired t-test or a two-sample t-test? Okay, and sometimes the confusion is with a two-sample t-test because we're seeing that there's two things here, a brand A and a brand B tire. those brand of tires are actually your two treatment groups because the same vehicle is receiving each of those two treatments, one tire on one rear side and the other tire on the other rear side. This actually would be classified as a matched pairs t-test. Once again, on the calculator, it is just called a t-test. Okay, the second scenario, can listening to music while working increase productivity? There are 20 factory workers and they agree to take part in a study to investigate this question. Researchers randomly assign 10 workers to do a repetitive task while listening to music. The other 10 workers do the task in silence. So here we have two separate groups. The same individual is not undergoing both of the treatments. It doesn't feel like these workers were paired up in any way so that two workers who are similar, one listening to music while doing the repetitive task and the other one doing the task in silence. Not getting any sense that there's any pairing of any sorts. We're going to classify this as a two-sample t-test. Okay, and it is called a two-sample t-test on the calculator. Okay, let's look at example 3. We have adopted twins into a high, we'll call that A, and a low income B families. We're comparing twin A's IQ to twin B's IQ. Okay, so here we have twins. They definitely feel like it's paired, like that's a genetic pair, but one twin has been adopted into a high-income family and the other one into a low-income family, and then they will be compared at the end. This is that matched pairs t-test. Okay. Not a two-sample, but a matched pairs t-test. Okay. Number 4, you take a multiplication test and then you compare that multiplication test, what your score was when you were taking the test with music playing in the background versus taking a multiplication test a second time and comparing that score without music playing in the background. If you do each of those two treatments, you are pairing yourself against yourself. That is called a matched pairs t-test. Okay, matched pairs t-test. Okay, and the last example on this page is you're going to test for salmonella in 10 different eggs, but in each egg, you're going to test each egg using 2 different methods. Okay, there's 2 different methods for testing for salmonella, and you're going to compare those measurements. So it feels like each egg is going to undergo these 2 different testing methods. This also feels like it is a matched pairs t-test. Okay, matched pairs t-test. Okay, please remember that we always use the pooled option when we're talking about sample proportions and significance tests. Okay, that was where we pulled together the 2 samples in one, but it is not recommended that you use the pooling procedures when you are working with means. Okay, our final page here on the notes is looking at 2 different ways of tackling this problem and trying to figure out which of these 2 inference procedures would be the better one to run given the following situation. You are wondering if the male in a brother-sister twin pair is taller than the female twin. So you ran, typically, if that's normally what happens, is that the brother is normally taller than his sister, who is his twin. You randomly select 30 sets of twins and you record the heights of both siblings. You can see that that is what we have given right here. Okay, the data is displayed below. So here we have all the sisters' heights, all the brothers' heights in those dot plots. The question is, which inference procedure would you run and why? And we're just going to assume here that the conditions are met. Okay, so in this top example, a 2-sample t-test has been ran with the data using the brother twin as one sample and the sister twin as another sample. Now there is a flaw with that. We can go back and talk about that here in a moment. But let's go ahead and look at the example here at the bottom. That would be taking the brother data, the sister data, and then notice we are subtracting the brother height minus the sister's height. Okay, and that results in just a single dot plot of the differences in their height. We have a single set of data here, even though we started out with two sets of data, because what we're actually examining here are the differences between those. That would be an example of a paired t-test. The reason that it is actually better to use this paired t-test method is because the data did not come from two independent samples. When you select a set of twins, they're automatically come together as a pairing. And so that's why, to tackle this problem, it would be better to run a paired t-test comparing the differences in heights versus a two-sample t-test. You can see at the bottom of this notes page, there are a few problems here for you to try that go along with this video that will